Good morning, students. The previous class we have learned the decomposition of given fraction into sum of partial proper fraction is said to be resolving into partial fractions. So under this we have discussed type 1 and type 2. So type 1 is f of x by g of x is a proper fraction where g of x, the denominator, contains non-repeated linear factor. So if ax plus b is a factor of g of x, then there exists a by ax plus b, which is a partial fraction, and a is to be determined. And the type 2 is the denominator contains non-repeated repeated linear factors. So for each repeated linear factor of g of x, so we will be having a by ax plus b, b by ax plus b whole square, c by ax plus b whole cube, etc. So these are what we have discussed before. So we have started exercise 7. This question, x square minus 2x plus 6 by x minus 2 whole cube. So the denominator contains repeated linear factor. So x minus 2 has been repeated thrice. So we can solve this through the process of a by x minus 2, b by x minus 2 whole square, c by x minus 2 whole cube. So this is type 2. Denominator contains repeated linear factors. So instead of this, and we have to solve a, b and c. Here x equals to 2 is the only root or solution we are going to take and solve. So one of these three we will be getting. The remaining two constants will be obtained through the process of comparing the coefficients on both the sides, which we have done before. So instead of this, we can solve this in the another alternative method. That alternative is especially useful when the denominator contains the repeated linear factor only. What does it mean? Along with x minus 2 whole cube, x minus 3 should not be there here. So let x minus 2 equals to y, x equals to y plus 2. So this implies x is equals to y plus 2 whole square minus 2 into x is y plus 2 plus 6 by x minus 2 is y whole cube. So you expand this, y square, 2 square 4, 2 2s are 4y, this is a plus b whole square, minus 2y, minus 2 2s are 4, plus 6 by y cube. This is equals to y square plus 4y minus 2y is plus 2y, 4 gets cancelled, plus 6 by y cube. A plus b plus c by d is a by d plus b by d plus c by d. So this is equals to y square by y cube plus 2y by y cube plus 6 by y cube. So y square times this is equals to, this is 1 by y. 1 by y is equals to x minus 2 plus 2 by y square is x minus 2 whole square plus 6 by x minus 2 whole cube. So a by b by c by. So a is equals to 1, b equals to 1, c is equals to b is equals to 2, c is equals to 6. So if we proceed through this process, it will be lengthy when compared to this alternative method. This alternative method is useful here. Second Roman first bit, x square minus x plus 1 by x plus 1 into x minus 1 whole square. First of all, this fraction is of the form f of x by g of x, where f of x and g of x are both are polynomials, and the degree of numerator is 2 while the degree of denominator is 3. X into x square is x cube. So degree of numerator is less than that of degree of denominator. Therefore, this is a proper fraction. So partial fractions can be used. So here the denominator contains both repeated and non-repeated linear factors. That is type 1 and type 2 being mixed together. Denominator contains x plus 1 non-repeated linear factor, x minus 1 repeated linear factor which is repeated twice. So for a non-repeated linear factor ax plus b, which is a factor of the denominator g of x, there exists one partial fraction of the form a by ax plus b. So this is a by x plus 1 plus x minus 1 whole square repeated twice. So b by x minus 1, c by x minus 1 whole square. So this is what we have done in type 2. So this is the mixture of both the types. Now the LCM is x plus 1 into x minus 1 whole square. Now see this x plus 1 into x minus 1 whole square by x plus 1. This gets cancelled. So x minus 1 whole square into a. So this is a into x minus 1 whole square plus this is x plus 1 into x minus 1 whole square by x minus 1. So this and this gets cancelled. So b into this is x square minus 1 plus this is x minus 1 whole square into x plus 1 by x minus 1 whole square. So these two gets cancelled. So c into x plus 1 is equals to x square minus x plus 1 by x plus 1 into x minus 1 whole square. So these two on both the sides got cancelled. So we are left with x square minus x plus 1 is equals to a into x minus 1 whole square plus b into x square minus 1 plus c into x plus 1. So here x minus 1 and x plus 1 are the two linear factors. So x equals to 1 and x equals to minus 1 are the two roots. So roots means they have to satisfy the equation. So put x equals to minus 1 by x equals to minus 1. X plus 1 is the factor equated to 0. So x equals to minus 1 is the root. So put x equals to minus 1 and substitute here. Minus 1 whole square is 1 minus x is minus of minus plus 1 plus 1. So a into minus 1 minus 1. X value is minus 1. Minus 1 minus 1 is minus 2 whole square, which is 4. This is minus 1 whole square is 1. 1 minus 1 0. So whole b will be cancelled here. Minus 1 plus 1 0. C is also cancelled. So therefore a is equals to this is 3 by 4. Now put x is equals to 1. Substitute. So 1 square 1 minus 1 plus 1 is equals to a into 1 minus 1 whole square. So 0. So here 1 square minus 1 0. So we are left with c into x plus 1. 1 plus 1 2. C is equals to 1 gets cancelled. So 1 by 2. Now So the two are the two are the factors. Therefore, x equals to -1 and +1 we have used. Therefore, we are not left with any substitution. So now we have to compare the coefficients. Comparing the coefficients of, you can compare according to your will and wish. You can compare x square on both the sides, or x on both the sides, or constants also on both the sides. So compare the coefficient of x square I will take on both sides. So x square quotient is 1 on LHS. Here on expansion we will be getting this x square minus 2x plus 1. So x square quotient is a here. I tell you, a into this is x square minus 2x plus 1. So this is ax square minus 2ax plus a. So the quotient of x square is a here. So we don't require quotient of x and constant, because we are comparing the quotient of x square on both sides. So x square quotient is a. Now here x square quotient is b. So here we are not getting any x square quotient here, because it is only x and constant here. Now this is equals to a, already we got. So substituting, y 1 equals to 3 by 4 plus b. So from this 1 minus 3 by 4 equals to b. From this b is equals to 4 1s are 4 minus 3 is 1. So 1 by 4. Therefore x square minus x plus 1 by x plus 1 into x minus 1 whole square is equals to, the value of a is 3 by 4 by x plus 1. So 3 by 4 into x plus 1 plus the value of b is 1 by 4 by x minus 1. 1 by 4 into x minus 1 plus the value of c is 1 by 2 by x minus 1 whole square. So 1 by 2 into x minus 1 whole square. So this is the partial fractions of this proper fraction. So if you see, these are the three proper fractions. So proper fraction, if you resolve, then ultimately the sum of two or more proper fractions only we are getting. Like last problem, this denominator again contains non-repeated as well as repeated linear factors, both type 1, type 2 involved. So this is a by x minus 1 plus b by, this is type 1. So here x plus 2. So x plus 2 being the repeated linear factor of this denominator. Therefore, for every repeated linear factor, there corresponds to a partial fraction of the form a by ax plus b. Already a is used. Therefore, here b by x plus 2, c by x plus 2 whole square. Remember, a by ax plus b. If there is another factor, a2 by ax plus b whole square, we have n, etc. an by ax plus b whole power n. So here, instead of a1, a2, a3, etc., I have taken a, b, c. Since a is already used, I have taken b and c. Now, this is equals to x minus 1 into x plus 2 whole square is the LCM. So x minus 1 into x plus 2 whole square by x minus 1. So a into x plus 2 whole square plus b into x plus 2 whole square. This gets cancelled. We left with x minus 1 into x plus 2 plus b into this by this, x plus 2 whole square gets cancelled, c into x minus 1 is equals to 9 by x minus 1 into x plus 2 whole square. Cancelled. So this is equals to 9 is equals to a into x plus 2 whole square plus b into x minus 1 into x plus 2 c into x minus 1. So x minus 1 and x plus 2 are the two factors. X equals to 1 and x equals to minus 2 are what we are going to put for x here. So put x is equals to minus 2, substituting 9 is equals to minus 2 plus 2 is 0 whole square into here. This is 0. So here also minus 2, if you put minus 2 plus 2 is 0 into something 0. So we are left with c into the value of x is minus 2 minus 1. So minus 3. Therefore c is equals to 3 3s are 9. So minus 3. Now put x is equals to 1. Substitute 9 is equals to 1 plus 2. X value is 1. 1 plus 2. 3 3 square. 9 into a 9a. Here x equals to 1 if you substitute here. 1 minus 1 0 into whole 0. Here also 1 minus 1 0 into c 0. So therefore a is equals to 1. Now comparing the coefficients. Comparing coefficients on both sides. So let us comparing quotient of x square on both sides. You may even go for the comparison of coefficient of x as well. So 9 is equals to, because on the numerator, on the LHS, we don't have the quotient of x square. Therefore, 0 is equals to, on expansion, we will be getting x square plus 4x plus 4. So, x square quotient is a. Here, x into x square, its quotient is b. So, from this, a plus b equals to 0. From this, b is equals to minus 1. Because 1 minus 1 is 0. Therefore, 9 by x minus 1 into x plus 2 whole square is equals to a is 1 by x minus 1, b value is minus 1 by x plus 2 plus c value is minus 3 by x plus 2 whole square. Now the third question. 1 by 1 minus 2x whole square into 1 minus 3x. So, here 1 minus 2x is the repeated linear factor type 2. 1 minus 3x is the non-repeated linear factor type 1. Combination of 2. So, this is a by 1 minus 2x plus b by 1 minus 2x whole square plus c by type 1. A by ax plus b. Since a, b are used, so here it is of the form ax plus b only. This is minus 3x plus 1. Both are of the form ax plus b, standard linear factor form, ax plus b. So this is equals to c by 1 minus 3x. So 1 minus 2x whole square into 1 minus 3x is the LCM. Whole square. So 1 minus 2x whole square into 1 minus 3x by 1 minus 2x. So this and this gets cancelled for once. So 1 minus 2x into 1 minus 3x. A into 1 minus 2x into 1 minus 3x plus b into this by this. 1 minus 2x whole square, 1 minus 2x whole square gets cancelled. 1 minus 3x plus c into, so this by this 1 minus 3x, 1 minus 3x gets cancelled. 1 minus 2x whole square. Now this is equals to 1 by 1 minus 2x whole square into 1 minus 3x. So these two cancelled. on both the sides. So 1 is equals to a into 1 minus 2x into 1 minus 3x, b into 1 minus 3x plus c into 1 minus 2x whole square. So 1 minus 2x being a factor, make it to 0, 1 equals to 2x, x equals to 1 by 2. So put x is equals to 1 by 2. So substituting, we get 1 is equals to, so here on substituting 1 by 2 here, 1 minus 2 into x value is 1 by 2. 2 gets cancelled, 1 minus 1 0. The whole is 0 here. And this is also 1 minus 2 into 1 by 2. 2 gets cancelled, 1 minus 1 whole square. 0 into c 0. So therefore we are left with b only. So b into 1 minus 3 into x. 3 into 1 by 2 is 3 by 2. So this is b into 2 ones are 2 minus 3 minus 1 by 2 is 1. Therefore, b is equals to minus 2. Minus 3x is a factor equated to 0, 1 equals to 3x, x equals to 1 by 3. So substitute here. 1 is equals to here this 3 into 1 by 3 is 3 gets cancelled, 1 minus 1, this is 0 and this is 0, we are left with c only. So c into 1 minus 2 into 1 by 3 is 2 by 3 whole square. So this is equals to 1 into c into 3 ones are 3, 3 minus 2 is 1. So 1 by 3 whole square. So from this c is equals to, this is 1 by 9. C is equals to 9. Now, comparing the coefficients of x square on both sides. So we don't have any x square quotient here, therefore on LHS is equals to 0. So if you multiply this, a into 1 into 3x minus 3x, minus 2x into minus 1, minus 2x into 1 minus 2x, minus into minus plus 2, 3 is a 6x square. So that means this is a into 1 minus 5x plus 6x square. So this is a minus 5ax plus 6ax square. A is a constant, but we are trying to compare the quotient of x square. Therefore, this we don't require. This is the quotient of x. This we don't require. So x square quotient is 6a here. Plus, this is b into 1b minus 3bx. So constant and x quotients we are getting. So you leave it. Now you come to here, c into, this is a minus b whole square, a square plus b square. 2x whole square is 4x square minus 2 to the 4 into x, 4x. So c into 1 is a constant. C into 4x square. So 4cx square. X square quotient is 4c minus 4cx, which is the x coefficient. So you leave it. Now 0 is equals to 6 into the value of a, which we don't know, that is to be determined, plus 4 into the value of c is 9. So this is equals to 4 9s are 36. This plus 36, if you transpose onto this side, minus 36 equals to 6a. 6 6 are 36. Therefore, a is equals to minus 6. Therefore, 1 minus 1 by 1 minus 2x whole square into 1 minus 3x is equals to, a value is minus 6 by 1 minus 2x plus b is equals to minus 2. So this is minus 2 by 1 minus 2x whole square plus C is equals to 9. So this is 9 by 1 minus 3x. 1 by x cube into x plus a. So x cube is the cubic polynomial, but x cube can be reduced further. Reduced in the sense be factorized. Okay, x cube is x into x into x. So x is repeated thrice. So this is a repeated linear factor, and x plus a is a non-repeated linear factor. Therefore, this is a by x plus b by x square plus this is c by x cube plus d by, since a, b, c, so is over, x plus a. This is the form ax plus b. First type 1. For each repeated linear, non-repeated linear factor of the denominator g of x, there exists one partial fraction of the form a by ax plus b. A by ax plus b. Since a, b, c constants are used, therefore I will take d by ax plus b, because this x plus a is of the form 1x plus a. This is of the form ax plus b only. So this is d by x plus a. So on finding the LCM, we'll get x cube into x plus a. So x cube into x plus a by x. So x square into x plus a into a. So a x square into x plus a plus x cube into x plus a by x square. So this is x times. So bx into x plus a plus c into x cube into x plus a by x plus a. X plus a gets cancelled. So d into x cube. So we are left with this now. So x cube into x plus a by x cube. X cube gets cancelled. C into x plus a. This is d into x cube into x plus a by x plus a. These two gets cancelled. D into x cube. This is what we get. Now this is equals to 1 by x cube into x plus a. These on both the sides got cancelled. Now x is the linear factor and x plus a is the linear factor. So x equals to 0 and x equals to minus a are the two roots that satisfy the equation. So put x equals to 0. So 1 equals to 0 if you substitute here. 0 square is 0 into the whole is 0. Here also 0 into something 0. Here also 0 cube is 0. So we are left with c only. C into x value is 0 plus a, which is a. From this, c is equals to 1 by a. Likewise, put x is equals to minus a. So 1 is equals to minus a plus a, 0 into this 0. So minus a plus a, 0. Minus a plus a, 0. So d into x cube is minus a cube. Minus a cube. So from this, d is equals to minus 1 by a cube. So now we are not left with the substitution of x, because x and x plus a are the two factors there. Therefore, we have utilized x equals to 0 and x equals to minus a. Now, comparing the coefficients. Comparing the coefficient of x cube on both sides. So here on LHS we only have 1. So x cube is absent. Quotient of x cube is absent. So 0 equals to So x square into x is x cube. So there is a possibility of the quotient of x cube is coming here. So x cube quotient is a. X square into a is a x square. So this is the x square quotient. But we are interested to take the x cube quotient only. So, and we don't have here x cube quotient other than this a. So x into x square. X into a ax. So here quotient of x square and the quotient of x only we are getting. So x cube quotients we are not getting here. So here also x coefficient and constant. Here x cube quotient is d. So d. A plus d. So from this a is equals to 1 by a cube because d is minus 1 by a cube. So a is equals to minus d. Minus of minus is 1 by a cube. Now comparing coefficient of x on both sides. Here we don't have any x here. So this is x cube plus ax square. So here x cube and x square quotients are what we are getting. So we are trying to take the coefficient of x. Therefore, we do not get any x quotient here. X into x square. Bx into a bx. So this is bx into a. So the quotient of x is ba. Plus here the quotient of x is c. Cx is this. The quotient of x is c. And the last one is x cube. So leave it. From this, BA is equals to minus C. So from this, B is equals to minus C by A. So minus C by A. What is C? 1 by A. So C minus, the value of C is 1 by A by A. So 1 by A square. C value is 1 by A into A is already there. So A into A square. So we got all the constants A, B and C, D. Therefore, 1 by x cube into x plus A is equals to, the value of A is 1 by A cube, 1 by A cube by x. So 1 by A cube x plus B value is minus 1 by A square into x square. So minus 1 by A square x square plus C value is 1 by A by x cube, 1 by A x cube. D value is minus 1 by A cube. So minus 1 by A cube into x plus A. So this is the answer. So again, x minus 3 whole cube, the denominator contains repeated linear factor only. So the alternative method we have. Otherwise, we need to go for a by x minus 3 plus b by x minus 3 whole square, c by x minus 3 and the values of a, b, c are to be evaluated. This is a little bit cumbersome and tedious method, lengthy method. So it requires x equals to 3 we can use, but later on it requires the comparing coefficient of x square, x cube on both the sides, etc. So otherwise, since the denominator contains the repeated linear factor only, so with this repeated linear factor, there is no another factor like x minus 1 or x minus 1 whole square, etc. So therefore, the alternative method can be applicable for this. Let x minus 3 is equals to y. X is equals to y plus 3. So x square plus 5x plus 7y x minus 3 whole cube is equals to the value of from this x equals to y plus 3, the value of x is y plus 3 whole square plus 5 into y plus 3 plus 7 by x minus 3 is y cube. So a plus b whole square. So y square, 3 square 9 plus 2 3s are 6y. So a plus b whole square plus 5y, 5 3s are 15 plus 7 by y cube. Y square plus 6y plus 5y is 11y. So 15 plus 7 is 22 plus 9, 31 by y cube. Y square by y cube is 1 by y. 11y by y cube is 11 by y square plus 31 by y cube. So replace x minus 3 with y, then we'll get 1 by x minus 3 plus 11 by x minus 3 whole square plus 31 by x minus 3 whole cube. 3x cube minus 8x square plus 10 by x minus 1 whole power 4. So the denominator solely contains the repeated linear factor. So the alternative method is applicable. Otherwise, a by x minus 1 plus b by x minus 1 whole square. Type 2 repeated linear factors. C by. So for every repeated linear factor of g of ax plus b whole power n of the denominator g of x, there will be a partial fraction of the form a by ax plus b, a2 by ax plus b whole square, a3 by ax plus b whole power 3. If n is 3, so these are. If there are n linear factors, repeated linear factors, etc., an by ax plus b whole power n. So a1, a2, a3, etc., an are to be determined. So instead of a1, a2, a3, etc., I will take a, b, c, d. So c by x minus 1 whole cube, because this x minus 1 is of the form ax plus b only. X minus 1 is 1x plus minus 1. So this is of the form ax plus b. This is the linear factor c by, so d by x minus 1 whole power 4. So in this way we have to do. Otherwise, the alternative method for this is, or simply x minus 1 equals to y, x equals to y plus 1. So this is 3x cube by minus 8x square plus 10 by x minus 1 whole power 4 is equals to 3 into the value of x is y plus 1 whole cube minus 8 into y plus 1 whole square plus 10 by x minus 1 is y power 4. Now this is 3 into a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube, a cube, y cube plus 3a square b, 3 into y square into 1 plus 3ab square, 3 into y into 1 square, 3y plus y cube, b cube, 1 cube, 1 minus a into y square plus 1 plus 2y plus 10 by y power 4. Now this is 3y cube. 3 3s are 9y square minus 8y square. It is y square. 3 3s are 9y. 8 2s are 16y. So minus 7y. 3 1s are 3 minus 8 plus 10. So 3 minus 8 plus 10. 10 plus 3 is 13. 10 minus 8 is 2. 2 plus 3, 5. This is plus 5 by y power 4. This is equals to 3 y cube by y power 4 by y plus y square by y power 4 is y square by y power 4 is 1 by y square minus 8 by y cube plus 15 5 by y power 4. So this is equals to 3 by the value of y is x minus 1 plus 1 by x minus 1 whole square minus 8 by x minus 1 whole cube plus 5 by x minus 1 whole power 4. 3 3s are 9 minus 8 2s are 16. So 6 minus 9 plus 16 is minus 7. So this is 7.